Yes, so we are live. Correct? Are we live? Can you all hear me? Is everything fine? Okay. So please hit the like button if you could hear me. Yes, hi, good evening. Yes. Can you all hear me? Chalo. So let us start with our today's class. Now today's class is going to be very important class. We have seen that in semester 1 physics paper was a disaster. Now in semester 2 we have certain chapters which are not only important but they are difficult also. So I got comments from some of the students say कि they want important questions or the sure short questions from this chapter called electromagnetism. So here I have come up with super 20 questions on electromagnetism. So you already know that I have the entire chapter, video of the entire chapter. So here if you come to my YouTube page and if you come to the playlist of machines, you will see that for physics, I have a chapter on resonance of a vibrating pendulum. Also, I have sure short numerical on current electricity. Current electricity, two type of numericals are very important. I have covered one kind of numerical and very soon I am going to cover the second kind of numerical also. And here I have a very important video on the strategy, okay, strategy for studying physics. I will strongly recommend ki please watch this video. Then I have electromagnetism entire chapter covered in two videos and each video is a gem. You have to take advantage of this video. One is both the videos are of longer length. One is of 46 minutes and 52 seconds and another one is 1 minute and 8 seconds. Okay, so these are really long videos but I have covered everything about electromagnetism over here. Then calorimetry, sound, and my favorite video is over here on radioactivity. This video, okay, please watch this video. They are very important. Okay, so now what we are going to do, I am going to consider that ki you have not studied, you don't know anything about electromagnetism, and I will be doing this electromagnetism right from the scratch, right from the base. So be ready with your answer and try to get the answer. Okay, and if your answer is correct, then congratulations, you know that concept properly. But if your answer is not correct, if it is wrong, then focus hard and try to understand the concept so that if same question comes in your board examination, you don't go wrong over there. So here we go. This first few questions, first 15 questions are combination of MCQ and diagram based question. It can be in a form of MCQ, but it can be asked in a form of a subjective question also. So just don't ignore it like an MCQ question. Question is asked in a form of MCQ, but the teacher may modify this question and ask you in form of a question answer also. So are we all ready to go? Okay, to launch our today's class? Yes, sir. Yes, sir. Yes, sir. Okay, here we go. First question, question number one. So I hope this question one is clear to you all. Okay, you could see only few options. Okay, now it's absolutely fine. So here we have a battery. Look at this question carefully. Look at this question very carefully. Now, this is okay. The compass depict the direction of the magnetic field. So here we have four compasses placed on a cardboard, and this compass will is depicting a magnetic field. Okay, magnetic field of a straight conductor carrying current. So this is a straight conductor carrying current attached to a battery. Attached to a battery, a longer line represent a longer line. Which color should I use? Okay, let me use black color here. So longer line represent the positive terminal of the battery, and the smaller line represent the negative terminal of the battery. So in which direction your current will flow? Obviously the conventional current which we consider while solving this, so it flows from conventional current flows from positive terminal towards the negative terminal. So this is the direction of flow of your conventional current. Don't take the direction of electrons. Electrons are negatively charged, so they they travel from negative terminal to the positive terminal. We are not going to take that direction. We are going to take the direction always whenever you have a ray diagram in current, electricity as well as magnetism, not ray diagram, any circuit diagram. So there you are going to take the direction of your current as a conventional direction. Okay, and conventional direction is charges flow from positive terminal to the negative terminal. Okay, so sir, all the compass are showing the same direction. No, you are wrong here if you say that all the compasses are in a same direction. We know that if this is a cardboard, we already have this kind of experience experiment in our syllabus. Okay, there is a cardboard, we sprinkle some iron dust particle over here, um, and what we do is we tap the cardboard. Then what happens? How do those iron filings or the iron dust particles arrange themselves? They arrange themselves in what? Comment in the comment box. How do this they will arrange themselves? Yes, they will arrange themselves in a form of a concentric circles. Now consider this circle. Now look at this diagram. Now consider this circle. Suppose this circle, okay, this is a magnetic field, and magnetic field will be in a form of the concentric circle. There will be many circles you will see when iron filings are sprinkled over the cardboard, but we are going to consider only one circle. That circle जो हमारे काम का circle है. And what is the direction of the magnetic field? We all know that direction of a magnetic field is tangential, in a form of a tangent. So we have to consider ki which compass shows a direction of a tangent. So here it is a tangent. At this point, definitely at this point, this cannot be a tangent. Okay, here tangent will come down. Okay, and one more thing. Okay, we have to use right hand thumb rule. This is my right hand and this is my thumb. My thumb will point the direction of the current. My thumb will point the direction of this conventional current. So it is in this direction. So my thumb is pointing the direction of the current, and my curled finger will mark the direction. Okay, will mark the direction of the magnetic field. So so these are so this is a magnetic field. So we look at the tangent. So this looks fine, but if we draw this line, if we see the direction of the compass B, so this direction is absolutely wrong. Now what about D was wrong, B is also wrong because B is also showing more or less same direction. Now there are two tangents, one at A and other one at C, but why C is wrong? Because when we see the direction, your magnetic field is in which direction? Turn is in this direction, okay, clockwise direction. So correct will be magnetic field should be in this direction because it is going like this. Should I change the color? Okay, see here. This arrow will be in this direction. So correct direction is this, but uh, in C, a magnet is shown in this direction towards right. So this is also wrong. So my correct answer is answer A. So my correct option is option D. Is it fine? Are you convinced, or you feel you feel answer is something else? If you don't agree with me, please comment in the comment box. Put your comments in the box. Okay, yes, concentric circle in parallel loop. Okay, yes. So are you convinced? Did you get what is the right answer? Did you get what is the right answer? what you have to do is you have to first of all take the right hand thumb rule. What is the right hand thumb rule? Okay, what is the right hand thumb rule? So direction of a current, it is in a downward direction. Okay, so circle which I am going to consider will be this. What will be that direction of this circle? Okay, how it is moving, how is the direction? Okay, look at my curl finger. So this is the direction, this is the direction at the point A, this is the tangent. At the point D, this is the tangent. At the point B, sorry, this arrow should come here. This goes there. So at B, it should be this direction, and at C, it should be this direction. So what do we see? Only one answer is correct, that is A. And all the three compasses are not showing the proper direction. So B, C, D are wrong. Compass A shows the correct direction. So our option is answer on option D. Is it fine? Can I move on to next question, please? Yes. Okay. Here comes a question number 2. A given diagram shows a magnetic field due to what? See, look here. This is incomplete diagram. You may get this diagram in your examination as a diagram to be drawn. This question was asked earlier also. If I am not wrong, this question was asked in 2016. Okay, draw a diagram. So here we have, okay, here we have what? Okay, a conductor and a wire carrying current, and here we have a coil in a loop. Okay, so coil in a loop, it will be something like this, not here, it will be something like this. Okay, so this direction, so here this shows, okay, this is the diagram for what? Current in a loop. The given diagram shows the magnetic field due to coil. Yes, this is coil. Straight wire, definitely it cannot be a straight wire. Straight wire was diagram number 1, not this one. So straight wire is also not a correct option. What about solenoid? No, solenoid is also not a correct answer, because in solenoid you have a coil, we have number of turns. Okay, but here in this diagram we have only one bar magnet. What a joke, it cannot be a bar magnet as well. So my answer or my correct option is option A. My correct option is option A. Am I right? Do you agree with me? Type your answer. What do you see? Is it A? If you feel answer is A, then type A. If you feel something else, then type that. All right, all right. Yes, is black visible? I'll be using a black color. Fine. Yes, yes, yes. Okay. All the students who are attending, feel that. Please take a participation. Okay. Please subscribe to the channel. So if you are a subscribed member of our YouTube channel, then you can also post your comment. Please attend the class. Sit for this class with your notebook and your pen along with you, so that you participate. Don't feel as if you are watching a video. See and feel, have a feeling that you are watching a classroom lecture. Okay, and keep on giving your answer. Fine, let us continue. Here we have, okay, here we have two parallel wires. This is wire 1 and this is wire 2, carrying a same current. Current is I. Okay, whatever current is carried by first wire, same amount of current, same magnitude of current is carried by the other wire also in a same direction. Their direction is also same. Okay, everything same. What is the total magnetic field at point M? And what is M? M is a midpoint. Okay, it is a midway between this. Now we know that current carrying current, the conductor carrying current, okay, possess a magnetic field, and it can be donated by right hand thumb rule. Okay, this is my right hand. So if my thumb is pointing in the direction of current, curl fingers will show me the direction of a magnetic field. So this is the direction of the magnetic field. But what happens? One magnetic field on this side and another magnetic field on this side. So what is your answer? What will be magnetic field at point M? Yes, what is the magnetic field? Options are 0, directed inside the page, directed out of the page, directed to the left. Now we know one rule. We know one rule, that magnetic field line never ever cross one another. They never ever cross one another. Okay, so these magnetic field lines will not cross one another. Okay, so at the midway, magnetic field, generally it is denoted by letter B. At point M, the magnetic field, which is a vector quantity, will be 0. So correct answer is option A. Option A is my correct answer. Right? Do you agree? Just let me know. Yes. A. Was it for this answer or for the previous answer? Yes. Let us move on to next question. That is question number 4. Here again we have a diagram. The diagram shows the pattern of the magnetic field produced by a current carrying solenoid. So here this question is related to solenoid. Which is the correct diagram? Okay, which is the correct diagram? If you compare solenoid with a bar diagram, okay, their magnetic field lines are exactly same. Their magnetic field lines are exactly same. Am I right? It is something like this. It is something like this. Okay, bar magnet and solenoid, they have same line pattern, right? So this is definitely not, because here magnetic lines are parallel, that means equal. Okay, they are weak and very weak magnetic field and parallel, which is not possible here. This concentric is not possible for solenoid. Again parallel, here it was parallel horizontal magnetic field, here they are vertical magnetic field. Okay, correct answer is S. Where is my option? S. D. So my correct option is D. I hope you all can see this, whatever I am writing, right? Solenoid always behave like a bar magnet when current is passing through a solenoid. Solenoid is a coil, okay, a coil which carries a current. Okay, so that behaves exactly like a bar magnet. Fine. Do you agree? Yes. Okay, D. Okay, so yes, my dear student, you are getting all the answers right. Now let's go for this. What? A wire AB. Where is wire AB? Here we have point A and here we have point B, and wire is suspended, okay, supported as shown in the figure between the poles of a strong magnet. This is a strong magnet, a horseshoe magnet. One is north pole and other one is the south pole. Okay, north pole and south pole. Any idea what is the direction of the magnetic field from north or south? Always remember that. Okay, current enters from a south pole and it exits from the north pole. Okay, suppose we have already studied this magnetic field lines. If this is a bar magnet, this is south and this is north. Entry is through the south pole and exit is from the north pole. Please remember this. Entry through the south pole and exit through the north pole. So magnetic field will be in this direction. Let me use a what? A green color to show the magnetic field ka direction. Okay, this is a direction of the magnetic field. Current is going through this direction. Okay, current is going through this right direction, perpendicular, both are perpendicular to one another. How will the wire AB move if alternating current is passed? Alternating current means what? Alternating current means, okay, at times direction of the current will be from B to A, and at times, okay, it will be reverse. So direct current has a direction in current flows in a single direction, but in case of alternating current, this current, okay, direction keeps on changing, so it is changing. Okay, how will coil move? So this can be explained by, can you tell me what does the direction, the movement of the direction, motion or a force experienced by the coil is given by which law? Is it a right hand thumb rule? Is it a Fleming's left hand rule, or Fleming's right hand rule? Type in your in the comment box. Okay, current carrying, okay, a conductor carrying current in a magnetic field when placed perpendicular, the force will be experienced, okay, in a direction, and that is given by what? Definitely, okay, I'll help you out. Definitely you cannot use right hand thumb rule. Okay, so you have two options: Fleming right hand rule or Fleming left hand rule. What is the answer? Right hand or left hand? Yes, correct. Fleming's left hand rule. Fleming's left hand rule. Now see, magnetic field is from south to north. Okay, we have three fingers. If you want a detailed explanation, a video, a complete video, I have prepared and I have posted on my YouTube channel. You can check a playlist of a physics. This electromagnetism entire chapter is covered in two parts. You can go through this. Okay, so hold your left hand in such a way that your thumb, your index finger and your middle finger are placed perpendicular to one another. Okay, and how do you remember the fingers? Start with thumb: father, mother, children. This is F. This is the direction of the force, or the direction, okay, the direction in which coil will be moving. Okay, F, father, mother. M means what? Magnetic field, and this is what? Current. So magnetic field is in this direction, and current will be what? Okay, since this is an alternating current, so once it will be what? Towards me, and in other time it will be away from me. Okay, when it is away from me, the force will be downward. When it is towards me, the force will be upward. So upward, downward, alternating. I hope you are understanding what I am saying. This is Fleming's left hand rule. So what is the what are the option? Up, no; down, no; up and down, yes; left and right, yes. Suppose, okay, since this is an alternating current, current will be traveling from point A to B and B to A. It is an alternating current, so it will keep on changing its path: A to B and B to A. Okay, and this is the direction of the magnetic field. A to B, force is upward, and and B to A. Okay, B to A towards me. Middle finger is the direction of the current. So force will be downward. Force will be downward. Force will be upward. Force will be downward. Force will be upward. Okay, so my correct option is option C. Is it fine? Have you understood this? Have you understood this? Okay, type the correct answer. Yes, yes, yes. Okay. Let's move on to sixth question. Question number six. Very, very important question. I have seen this question asked in the pre-board examination of at least 5 to 6 schools. Okay. So come here. See, diagram shows two bar magnet, one bar magnet. That is magnet P, and other one is the magnet Q. Hangs freely at both the ends of a solenoid. Again, a question related to solenoid. Which observation is correct when current is switched on? In the diagram, we see that we see that it is switched off. As soon as we switch the current, switch the current, current starts flowing from positive direction to the negative direction, in this direction. Okay, already we have been given with this arrows. Okay, with this arrows, right? Now how magnet will move? Now careful attention. See, this is the part where students go wrong. Okay, now see, we all know that when there are like poles, okay, like poles repel each other, and unlike poles they attract each other. Am I right? Do you know this? Please type S in the comment box if you know this. They attract each other, right? Okay, now see what is going to happen. What will be a north pole? Again we have a concept. That when the turn in the coil, okay, when the turn in the coil is anti-clockwise, anti-clockwise, Okay, when turn, so then it is a north pole, and it is a south pole when turn is clockwise. When turn is clockwise, right? Now see this question. What we have to do is we have to observe this coil from this side. And how is the turn? Is turn going in this direction? Is turn is going in this direction? Turn is going in this direction. Okay. And what is this direction for me? For me, this direction is anti-clockwise. Here, what I see is anti-clockwise turn in the coil. Okay. This is anti-clockwise. Okay. Anti-clockwise. Okay, anti-clockwise means this is a north pole. Am I right? Yes, anti-clockwise means north pole. And when I turn here and when I see from here, how is the direction? Coil is like this. Coil is like this. How is this direction? How is this turn for me? What is this direction for me? This direction for me is a clockwise. Okay, so you have to shift your position. Coil will be here, solenoid will be here. So this is clockwise. This is clockwise. Okay, clockwise. So this will be what? This will be south pole. Okay, this will be south pole. Now, without any doubt in our mind, without any doubt in our mind, we know that this solenoid has become, okay, is behaving like a magnet. Here north pole and here south pole. So what will happen? South, okay, this is south pole of a magnet and north pole of a magnet. They are unlike pole. So P will attract, okay, magnet P will attract. And if you see here south pole and south pole, so there will be repulsion at Q. There will be repulsion at Q. So magnet P moves away from a solenoid. Magnet P moves away from a solenoid. Answer is no. Because there is an attraction, it will move toward the solenoid. Okay, so this option is gone. Magnet P moves away. Again, same option. So this is incorrect. Magnet P moves towards the solenoid, looks good. Magnet P moves towards the solenoid. This also looks good. What here? Magnet Q moved towards a solenoid. This is wrong. Magnet Q moves away from the solenoid, south and south pole. So this magnet will repel. Okay, this will move away, and here there will be attraction. So my correct option is option D, that magnet P will be attracted towards the solenoid, will move towards the solenoid, and magnet will move, Q will move away from the solenoid. What is the moral of the story? Definitely 100% sure. This is a sure short question for your examination. Okay, so please remember, when direction is anti-clock, when I see this magnet from this side coiling, current is in this direction, current is moving in this direction. Which direction? Anti-clock. Anti-clock means what? North pole. When I turn to this side, I see that coiling is clockwise. Coiling is clockwise. Clockwise means what? South pole. So this way you decide a pole and then see how magnet is placed. And we know the law that like poles repel each other and unlike poles attract each other, and then give your answer, then select your answer. This can be asked in a form of a subjective question also. Be ready with your answer. Fine. Okay, so correct answer is D. Do you agree? Yes. Already I have started getting the options. It is D. Am I right? Okay, yes. Right, keep on answering the questions, keep on answering the question. Come here. Now this is related to galvanometer. What is galvanometer? What is galvanometer in a current electricity? So galvanometer help us to find the direction, of the current, now see, here we have a bar magnet, north pole and south pole, and here we have a solenoid. Okay, and this bar magnet is moving towards a solenoid with a velocity of 10 meter per second. Okay, 10 meter per second. So what is going to happen? So these are magnetic field lines of a magnet, of a bar magnet, magnetic field lines, okay, of a bar magnet, right? when it is moving, so this magnetic field line will enter into a coil, and this magnetic field line, okay, as you go nearer and nearer to the solenoid, more and more magnetic field lines will enter into this. So there will be flux, there will be flux in the coil, okay, there will be flux in a coil. And which law, which law now, type the name, which law is it? Eddy's law, Eddy's current, is it? Okay, it is Lenz law. What does Lenz law say? What does Lenz law say? Okay, if you watch this video, I have told you, आएगा तो आने नहीं देंगे, जाएगा तो जाने नहीं देंगे. Okay, if this magnetic field lines is trying to enter this solenoid, it will not allow this to enter inside. Okay, it will not allow to enter into this side. Okay, so direction of a magnet is this direction, and according to Lenz law, it will oppose the cause, it will oppose this magnetic field line. Okay, so current will start flowing in the opposite direction. And if question is asked, you are moving this magnet away from the solenoid, away from the solenoid, then it will जाएगा तो जाने नहीं देंगे. Okay, so it will again oppose that that cause. Okay, it will try to hold on with this, so that in that case it will pull over there. So this is a direction of a magnetic, okay, magnetic field lines, and this will be the direction of the current. Okay, this will be the direction of the current. Current is in this direction. Okay, so deflection will be toward this side, left side. Okay, this side, left side. So first option is left, correct. Right is wrong. Left and right, definitely not, definitely not. No deflection observed, that is also not possible. So my correct option is which option? Is it option A? Do you agree? Is it option A? Yes or no? Okay, yes, yes, yes. I'm getting us option A. Chalo, let us continue. Let us continue. Let us move on to this question. Again, a very important question. I can say this question is a repeated question. Okay, now look at this. A horseshoe magnet. A horseshoe magnet. The north pole and the south pole in a given diagram. Okay, this is X and this is Y. One is denoted as X and other end is denoted as Y. So we have to tell which is the north pole and which is the south pole. Please give your answer, please give your answer. Tell me which is the north pole and which is the south pole. Already I have covered this path, this part. Okay, anti-clockwise, when current is moving in anti-clockwise manner, so that will be north pole. And clockwise direction, that will be a south pole. Now look here, when I see this, okay, when I see this coil at X is in this direction. Okay, so what is this, what is this? Okay, this direction, it is going in this direction. Okay, this direction for me, this direction for me is clockwise. Okay, this direction for me is clockwise. So X is my south pole. X is my south pole. When I come to this part B, the B arm of the horseshoe magnet. So direction of coiling is this. This direction. What is this direction for me? This direction is the anti-clockwise direction. Anti-clockwise direction. Okay, anti-clockwise direction. So this is what? This is a north pole. So X is what? South pole, and Y is what? North pole. X is south, Y is north. Okay, B wala option. Okay, X is north. Okay, absolutely not. What about both cannot be north pole, both cannot be south pole? Okay, so my correct option is option B. Do you agree? Do you agree? Okay, yes, I already got one answer. X is south pole and Y is north pole. Right? Fine. Okay, can we move on to next question? That is question number 9. Here we go. Question number 9. A student learned that magnetic field strength around a bar magnet is different at every point. Which diagram shows correct magnetic field line? Okay, very easy. I think this is the easiest of all. Is the A diagram correct? Is B diagram correct? Is C correct? or is D correct? Okay, in which way? Okay, how are the magnetic field lines of a bar magnet? It is exactly same like a solenoid. So yes, answers are coming in. Okay, so here correct answer is option number C. Okay, option number C. Okay, it never goes like this in a rectangular form. Straight, though it is not possible because magnetic field lines are in a closed loop. Okay, this is also more or less same. We can't see any loop over here. So all three diagrams are incorrect. Diagrams number C was the correct diagram. Fine. Is it okay? Can we move on to question number 10? Here comes a question number 10. This is the direction of a magnetic field. Magnetic field and a conductor carrying current. Okay, this is positive terminal. This is negative terminal. So direction of a current will be this. Okay, current, father, mother, children. Current is represented by this finger, middle finger. Okay, in this direction. Magnetic field is where? Upward. Okay, magnetic field is where? Upward. So where will this force experience? It will be outside. Okay, towards you. Okay, let's see, where will rod move? Upward. Okay, father, mother, children. So force, the conductor will move in the direction of a force. This is what? Father, mother, children. This is the direction of a magnetic field which is upward, and this is the direction of what? Current. So my left hand, according to Fleming's left hand rule, this is the direction. This is the direction. Okay, current, magnetic field, and my thumb of left hand shows the direction in which the current will move. So current will move where? Will move where? Upward? No. Downward? No. Into the field? No. Outside of the field? So yes. Okay. Correct option is option D. This question is totally based upon Fleming's left hand rule. So please make sure you know both the rules, left hand as well as right hand rule properly. Is it fine? Is it fine? Yes? Yes? Okay, okay. So correct answer is answer D. So here we have crossed the halfway mark. Now come here, a very long question. A student make the arrangement of to study electromagnetic magnetic induction as shown. So see, this is a coil. This is a galvanometer. We already have seen the use of a galvanometer. What is the use of a galvanometer? It detects the direction of the current. Okay, listen carefully. So he changes the arrangement in four different way. Okay, four different way. Moves the coil to the left. Okay, here coil is moved. Okay, for in A, in trial one, coil moves in the left direction away from the magnet. So coil is move. Okay, coil moves here in the left direction away from the magnet. Or in trial two, moves magnet to the right way. Okay, so magnet moves in the right direction. In both the cases, whether you are moving a coil or you are moving a magnet, there will be a flux. Okay, there will be a flux, and there will be an induced current. And the direction of induced current is given by Fleming's right hand rule. Okay, induced current is given by Fleming's right hand rule. Let's see whether we require right hand rule over here or not. Okay, so we have seen first and second arrangement. What is the third trial? Moves both coil and magnet towards each other. So coil is moving towards the magnet and magnet is moving towards the coil. Here also there will be electric flux. So current will be induced. What is happening now in fourth trial? Both coil and magnet. Coil is moving in one direction and magnet is also moving in same direction. Okay, in same direction. In which trial? In which trial the galvanometer remains unaffected? In which trial galvanometer remains unaffected? Undeflected. Okay, undeflected. So isn't it, suppose coil is moving in this direction and magnet, both are moving in same direction. So when both are moving in same direction, it is as good as no movement at all. Okay, there will be no flux because when we compare coil and magnet with respect to one another, if they are going in same direction with the same speed, with respect to one another, they are not in the motion. They are not in the motion. So there is no flux. So in trial 4, there will be no deflection, no current induced, so no deflection in the galvanometer. So my correct option is option D. What a lovely question. What a lovely question. Okay, very nice question. Yes, already some students have started giving the answer. Trial 4, D. Trial 4. Yes, sir. Okay. Let's move on to next question. That is question number 12. So I have handpicked some very good questions for you all. I hope this diagram is clearly visible to you all. A student placed the iron filing, so iron powder or the iron filing is placed around a solenoid. The iron filing arrange themselves as shown. Okay, solenoid. When current passes through a solenoid behaves like a bar magnet. Okay, so according to that, this iron filings will arrange themselves. Okay, so here we have selected four areas. This P wala region, R wala region, Q wala region, and S wala region. Okay, is it clearly visible? Is it clearly visible? Yes. Is it clearly visible? Now question is that the iron filing arrange themselves as shown in the image. Okay. So question is, I think this question is incomplete. Let me complete this question. Where, okay, magnetic field is strongest. Okay, where magnetic field is strongest out of four points, where you find that magnetic field is strongest. We know, we already have studied in a bar magnet. Okay, at the poles, at the north pole and the south pole, the magnetic field is the strongest. Magnetic field is the strongest. And as you go away from this magnet, it becomes, magnetic field becomes weaker and weaker. So where is the pole? Okay, so here we have R. Okay, R is a region exactly located towards the pole. See, P is somewhere here. This S is also at a pole, but it is away from a pole, and Q is somewhere here. So R is the region where magnetic field will be strongest. So correct option is option C. All right. Is it fine? Is it fine? Okay. Yes. I could see that camera is covering the entire angle. Fine. Are we ready to go on for the next question? Let keep your comments keep on coming. Don't stop your comments. Okay, you have to keep on posting your comments one after the another. Yes, R. Okay, I got three R's one after another. Okay, triple R, a famous Tollywood movie, triple R. Right. Anyway, now moving on to question number 13. A magnetic field inside a long straight solenoid carrying current. What do you think inside this solenoid? Inside the solenoid, how is the current? Is it zero? Decrease as we move towards the end. It is same at all the point. Increase as we move towards the current. Okay. When you go inside the current, okay, if I select a region inside the current, what do I find? I find that lines are parallel to one another, okay, and select any region, okay, any region, here, okay, here, they have same number of lines parallel to one another and equally spaced between them. So answer is that this current will be, maybe it will be weak, and it will be same at all the point. It cannot be zero. It cannot be zero. I have seen that when this question was asked in the pre-board examination, many students have selected this question. But I can assure you, definitely this question is answer is wrong. Zero is the incorrect answer. Your correct answer, it is same at all the point. What makes me conclude that it is same at all the point? Because We can see I have selected different regions at different point. Everywhere I see that there are parallel lines spaced equally, and we already have studied when there are parallel lines, same number of lines everywhere, so current is also same. It is zero when the region which we select do not have lines at all. But in the interior of this solenoid there are magnetic field lines. The field lines indicate that it cannot be zero, it cannot be zero. Okay, and select a particular region inside the coil, you will find that there are parallel magnetic field lines. Parallel means what? They are same. It may be weak but not zero. Is it fine? Do you agree? Is this your answer? Yes, yes, students are also giving answer C. Come to question number 14, a diagram. Okay, what is this diagram all about? So this diagram is about a single conductor. Okay, a conductor carrying a current. Okay, a conductor carrying a current. Okay, there is a problem with this diagram. Direction will be this. Okay, positive to negative. Okay, positive to negative, this way. If the key is given, if the key in a given arrangement is taken out, okay, circuit is made open, so no current will flow, and the magnetic field lines are drawn over the horizontal plane ABCD. Okay, again you can consider that this is a cardboard, we have sprinkled an iron filings on this cardboard, current is passing through this cardboard. Okay, key is inside in its position. Okay, and when we tap a cardboard, this iron filings will rearrange themselves. Okay, and when we open this key and when we check the arrangement of this arrangement of what iron filings, how this will be, how this will it be in concentric circle? Concentric circles means what? Those circles which have different radius but same center are called the concentric circle. Elliptical in say shape, elliptical means something like this. Elliptical is something like this, straight line parallel to each other. Will the magnetic field will be in a straight line parallel to one another, concentric near a point O but elliptical at shape as we go further. Okay, so uh, at O elliptical, then perfect circle at the end. Okay, so correct answer. This question is also asked in the exam in a form of a diagram question. You need to draw this diagram. Okay, so we all know that magnetic field lines arrange themselves in the concentric circle, and what will be the direction of the magnetic field line? So again, right hand thumb rule. So this is my right hand and my thumb will point the direction of the current this way, and my curl finger will show the direction. Which direction? Direction of the magnetic field. So correct answer is what? Yes, already some of the students have given the correct answer, that is concentric circle. Correct answer is answer A. Correct answer is answer A, right? Okay, yes, Angad Preet Singh. Yes, hi, 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 hi. Okay, start giving answer, Angad. Don't give me a hi. Okay, give me the answer. I want your answers from you. In the arrangement, look at this arrangement. This question is a really tricky question. I want to see how many of you get this answers correct. Okay, answer for this question correct. I'll read a question, I'll give you some time, and I want to take your answers, and then I will explain what is the correct answer and why that correct answer. In the arrangement shown below, in the figure there are two coils. Look here, one coil which is attached to a battery, positive terminal and key intact. So there is a current flowing in this coil. Okay, from positive towards the negative terminal. Okay, and coil turn of coil is this way. Okay, turning, maybe turning is not important, turns are not important here. And and other coil. Okay, now this is what this galvanometer placed over here. So this galvanometer will try to detect what? Will try to detect what? It will try to detect induced current. Okay, it will try to detect induced current, and the direction of the induced current will be shown. If current is induced, there will be a deflection in the galvanometer. Okay, there will be a deflection in the galvanometer, and this can be explained by Fleming's right hand rule. Okay, Fleming's right hand rule. Induced current right hand rule, and force is with the Fleming's left hand rule. With the Fleming's left hand rule. Okay, is it fine? Is it fine? Okay, so here we go. Current is in this direction. Okay, what is happening over here? The deflection in the galvanometer remains zero throughout. Okay, so what we are doing, initially the key is not inserted, then key is inserted, okay, and removed. What we are doing, we are inserting the key and we are removing the key. When we insert a key, current is flowing, and when we are removing a key, current is not flowing. Okay, galvanometer will show the deflection only when there is a flux, when there are lines. Okay, and this magnetic field lines, it is changing, if it is changing. Okay, so what is happening, if I keep on inserting and removing the key, will there be any deflection? So I am inserting a key once and I am removing a key. Okay, and is there any change? What galvanometer is showing, if I am inserting a key and I am removing it, the deflection in the galvanometer remains zero, no deflection. There is a momentary deflection in the galvanometer, but it dies out shortly, and there is no effect when the key is removed. There is a momentary galvanometer deflection that die out shortly. The deflection are in the same direction. There is a momentary deflection galvanometer deflection that dies out shortly, and deflection are in the opposite direction. What do you think, which is the correct option? A, B, C, or D? Which is the correct option? Come on, you can have your take. Which is the correct option? A, B, C, or D? Now remember, see what is going to happen. What is going to happen? Okay, what is going to happen? Listen carefully. Very tricky question. When I insert my key inside, okay, current is going inside. Okay, flux is produced, and when I removing a key, all the magnetic flux which is produced, that is removed. So magnetic flux is entering inside. Okay, when it is produced, and it is removed when this key is removed. So there will be definitely deflection in the galvanometer for a short time. Okay, only for the time when I've inserted a key and I have removed a key. But what will happen, this deflection is in the opposite direction. Okay, opposite direction. लेंस लॉ, आएगा तो आने नहीं देंगे, जाएगा तो जाने नहीं देंगे. Okay, when key is inserted, this magnetic field lines are entering or trying to enter into the solenoid. So at that time, uh, the current is in this direction, deflection will be in this direction. When I remove a key, all this flux is removed. Okay, so the magnetic flux will the magnetic field lines are coming back. When they are coming back, okay, according to Lenz law, it will not allow it to go outside. Okay, so there will be so it will try to pull. Okay, current will try to pull it in a opposite direction. Okay, so it will be in this direction, so deflection will be. Okay, so there will be a momentary deflection, and deflection will be in the opposite side. Which is the correct answer now? Which is the correct answer? A, B, C, or D? A, B, C, or D? In the opposite direction. Momentary deflection in the opposite direction. So my correct answer is option D. My correct answer is option D. Most of you got it, you are telling it as B, but I am sure that you have understood. Correct answer is not B, but correct answer D. If you have understood, please give a thumbs up. Okay, give a thumbs up in a comment box. Right? I told you right in the beginning, this question is very tricky question. Thank God we have covered this question. Now we have understood the correct concept. So if this question is asked in the examination, we are not going to go wrong is this question, right? Okay, yes. Everyone is understanding this. Now coming here, I think first 15 question were diagram based question. Now no more diagram based question. Okay, now no more diagram based question. Okay, which option explains Fleming's left hand rule to understand the working of a motor or electric motor? Fleming's left hand rule. I already told you that Fleming's left hand rule is used to detect the direction of the force, and Fleming's right hand rule is used to detect the direction of the induced current. Direction of the induced current. Here we are using left hand rule. So when current carrying conductor is moved with the force, it create a magnetic field. No, 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 no. Okay, it does not create a magnetic field. Left hand rule creates a force. Left hand rule creates the force. Okay, force or motion. Force or motion. Okay, right hand rule. Right hand rule. Okay, it creates what? It creates current, and it shows the direction of the current induced or produced or created. Okay, when conductor is moved inside a magnetic field, motion so we are providing. Okay, current is produced in the conductor. Current produced will be through left hand rule, through right hand rule, and not left hand rule. So so first option is incorrect. Second is option is also incorrect. When magnetic field is moved relative to a conductor, current is produced. No, definitely no, not. When a current carrying a conductor is placed in a magnetic field, it expresses the force. Yes, we were searching for this. Left hand rule gives you direction of the force. Okay, force in which your coil will move. So my correct option is option D. My correct option is option D. So this is also a very good question whereby teacher is trying to test whether you have understood your Fleming's left hand rule and right hand rule properly or not. Okay, if there was any doubt, now I am sure all your doubts are cleared. Right? Let us move on to question number 17. What does thumb indicate? Okay, in Fleming's right hand rule, thumb always indicate force. Okay, thumb always indicate force. Okay, father, mother, children. Fleming's right hand rule. Okay, father, mother, children. Here force or the motion. M means magnetic field, direction of the magnetic field. And father, mother, children. Children means current. Okay, this gives you direction of the current. Okay, so thumb, direction of the magnetic field, no. Direction of the motion, yes. Direction of the magnetic field, no. External magnetic field, definitely not. Direction of a current, no. So my correct option is option B. Am I right? Am I right? Yes, before I could give the answer, students were ready with their answer. Very good. I am proud of all my students. Okay, what angle must be there between the magnetic field and conductor in order to for the maximum force? For maximum force, what should be angle? We know that whether a left hand rule or a right hand rule, all three fingers are held perpendicular to one another. All three are held perpendicular to one another. Perpendicular means what? 90 degree. At 90 degree there will be a maximum magnetic field, maximum force, maximum induced current. Okay, maximum force in case of Fleming's left hand rule, and maximum induced current in case of the right hand rule. Okay, so it should be exactly 90. Any angle other than 90 degree will current, this force or a current will, induced current will be not as strong uh, as uh, as it is in at a 90 degree. Okay, SI unit of magnetic field. Very interesting question. SI unit of magnetic field. Is it Newton? No, definitely not. Okay, it is Newton is for force, not for magnetic field. Is it Weber? Okay, hold on. Is it Tesla? Is it Faraday? Faraday, definitely not. Is it Weber or Tesla? Which one? Okay, it is Tesla. Correct answer is Tesla. Okay, I think Weber, along with a Weber, there is something else also. Okay, so Weber is not a correct answer. Tesla is the correct answer, right? Is it right? And last but not the least, finally we have come to our last question. The force on a current carrying conductor when placed perpendicular in a uniform magnetic field is given by which formula? Force is given by which formula? It is B I L, Bill. हम बिल दे चुके सनम, क्या दे चुके सनम, हम बिल दे चुके सनम. Force is given by this formula. Okay, B stands for magnetic field, I for current. Okay, and L is the length of the conductor. Okay, in the magnetic field. Okay, in the magnetic field. And other formula can be B is equal to what? F upon IL. And I is equal to what? F upon BL. Whereas L is equal to what? F upon BI. But for force, okay, force, this is the formula. So correct option is option A. Okay, so have you understood this? Have you liked today's video? I have given a PDF of this question by bank. The link is given in the description box. You can go to a description box, find this PDF link, and you can download it. And you can again practice this question. And what you have to do is, in every video of mine, please uh, check the description box, because in the description box you will find a PDF link. Okay, I have videos not only for physics or maths. You can see that if you go to my channel. So I have more than, okay, I have around close to 110 videos. Okay, 110 videos. So see this playlist. I have videos on geography, only one video in fact on geography. Then on history, I have some videos. Then short tricks of maths. Chemistry also I have video. Biology I have video. Okay, on physics I have video, on maths also. Maths, so almost I have covered the entire syllabus. Okay, all the difficult chapters which are there in semester 2, and I have taken super 20 question, important question. And it was the my students have told me that same kind of questions was asked in their pre-board examination. In fact, some of the students got exactly same question with no change. Okay, no change at all. Okay, fine. So you can check this, and please don't forget to subscribe to my channel also, and hit the notification button, because I'll be coming with videos like this very frequently. I'm planning to come live every day between 8 to 9. I'll keep you posting on my community tab, right? So please be in touch with me. Okay, and if there is any requirement, if you find, now most of the students were telling me, sir, please help us with the diagrams, how to draw a diagram in biology, and map related question in geography. So very soon I'm going to come with those video also. So I hope you are finding out my lectures, my video helpful, and also the PDF and notes. Okay, I have my website also, www.prepwin.in. You can check out that website as well. Okay, I have my app also. If you want notes for any particular chapter, let me know. I'll make those chapters or those notes free of cost for all of you, right? Because I want to help each and every student to score 40 on 40 in each and every subject. Okay, so there should be only happiness everywhere after the result. No disappointment, no heartbreak. Okay, so I want to spread love everywhere, and I hope you will be benefited from my work, right? So that's it for the day. If you have any comment, please drop in your comment. Otherwise, it's a very good night from my side to all of you. Okay, if there is nothing, if you don't have any doubt, you can also type good night in the comment box, right? Okay, bye sir, bye sir. Yes, yes. Okay, so here I am ending my stream. See you tomorrow, or see you very soon with my another video. Bye, 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 bye.